The problem asks us, in a room of 23 people, what is the probability that at least two of them have the same birthday? Well, here's what we're being asked to find. And let's abbreviate birthday, B-Day. Okay, remember we learned something called the complement rule. And it said the probability of an event is 1 minus the probability of a complement. And that's going to make this one much, much easier for us to figure out. We're, instead of going to find the probability that at least two of the 23 have the same birthday, we are going to find the probability, or 1 minus the probability of the complement. So what is the complement that at least two people have the same birthday? Well, remember, complement means not. If it's not the case that at least two people have the same birthday, what is the case? Well, that means that we have 23 different birthdays. So we're going to find the probability of 23 different birthdays, and then we're going to go ahead and subtract it from 1. So remember, when finding a probability, we do the denominator first. And the denominator is the number of possible outcomes to the experiment. Well, the experiment is finding out all the possible ways that 23 people could have their birthdays. So to make things simple, let's ignore leap years and assume that all years have 365 days. So how many possibilities are there for the birthday of the first of the 23 people? Well, the first of the 23 people can have any of 365 birthdays. Now, let's check the second person. How many possible birthdays can the second person have? Again, any of 365. And we repeat this for all 23 people, and so we get 365 times 365 times 365 23 times, and of course the mathematical shortcut for writing that number is 365 to the 23rd power. Now the numerator. The numerator is the number of outcomes in the event. The event is what we're trying to find the probability of. The probability is not just that these 23 people all have a birthday, but they have different birthdays. So again, the first person can have his birthday on any of 365 days. But the second person, since we're not just interested in him having a birthday, but him having a different birthday, once we know the first person's birthday, let's just say for the heck of it, the first person's birthday is October 3rd, then the second person, to be different, his birthday can't be October 23rd, and so we have only 364 choices for his birthday. And the third person, if his birthday is to be different from the first two, then there's only 363 possible birthdays we could have, and so on until we've written down again 23 numbers. Well, the mathematical symbol for 365 times 364 times 363, etc., 23 times, is permutation of 365 taken 23 at a time. And here I have forgotten to write the 1 minus, so really what we've got here as our answer is 1 minus the fraction whose numerator is 365 taken 23 at a time, and whose denominator is 365 to the 23rd power. Now, these two numbers in the numerator and denominator are so big that you need a scientific or graphing calculator to go ahead and calculate it. And I'm going to go ahead and use a graphing calculator I have right here. And when you divide those two numbers, you get an infinite decimal, which is approximately 0.4927. You then subtract that from 1. 1 minus 0.4927 is 0.5073. So in other words, when you have 23 people in the room, there's a slightly better than 50-50 chance that at least two people will have the same birthday.